Hello boys and girls, it's Mr. Minnich again with another exciting adventure into using our calculator. Today we're going to look at using our calculator to solve exponential functions graphically. There are two reasons we need to do this. One is at this point we don't have the tools in our algebra toolbox to solve them any other way. And also there are times in which it is impossible to find the solution to an exponential function set equal to a linear function. It is completely impossible to do that without graphing. So in this example, we're going to look at an exponential function, very simple, 100 times 1.1 to the x. Now if we look at this in our normal graphing window, if we go zoom, standard, we don't see anything. So of course we have to resize our window. We know here that the initial value is 100. So we're going to look for values at 100 or bigger. So our x values, we can do both positive and negative numbers, right? That's fine. X scale is fine. Let's look at our y min. We know that the smallest value that an exponential function can ever theoretically get to is 0. So we'll set that at 0. It can never be negative. And then the y maximum, we know it needs to be at least 100, right? But we want to have some room for growth. This is a growing exponential function. So let's go up to like 500 and see what happens. Okay, the y scale, 1 is going to be a little much, so we'll set that to be 50. And then we can graph. And we see a nice exponential curve. You'll notice we probably could have resized this so that we only went up to maybe 200 or 300 or so, and we still would have gotten most of what we needed in there. Now, let's take a look at what happens if I wanted to do something like this function. We want to solve for this function equal to 400. Okay, so in other words, we'd have 100 times 1.1 to the x equals 400. In that case, we're going to have to do something a little different, right? We're going to have to use a second equation here, right, and set it equal to 400. So basically what we're doing is having two equations and finding the intersection of those two equations. If we look at the graph, we can see that at some point over here, these two functions are going to intersect. It just hasn't happened yet. So we need to resize our window a little bit. Looks like we need to make our x window a little bigger, maybe out toward 20. We can kind of estimate there. It's not too much further. Right? And then we need to make our y window, it should be okay, because we should fit in that y window, right? It's less than 500. So when we regraph here, we can see that these two functions, the exponential function and the horizontal linear function, intersect right here. So that point is the value at which the exponential function is equal to 400. So we want to know what the x or the t value is at that point. So let's take a look at how our calculator can help us find this. If we go to second trace, that's the calculate menu, and we go down to number 5, which is intersect, that allows us to calculate the intersection of any two functions. So when you call this up, right, it has first curve. So we want to select the first function that we care about, which in this case is our exponential function, y1 equals 100 times 1.1 to the x. So we press enter to choose that. You'll notice there's a little cursor mark on there now. Same thing here, when we select the second function we care about, it's y2, and there's a little cursor mark there as well. Now it asks us for a guess. We want to move our cursor close to the point of intersection. It doesn't have to be right on top, but you want to be close. This just makes it a little faster to calculate, and if you have more than one point of intersection, as we'll see in a minute, right, then it allows you to specify which one you're talking about. So for guess, we press enter one more time, and it gives us both an x value and a y value. Of course, the y value is 400, and it looks like the x value is 14.54 approximately. We'll notice that's an irrational number, so we have to round it. So that's a great, easy way to use the calculator to find the intersection of an exponential function and the horizontal linear function, right, which gives you a solution to the exponential function at y equals 400. So that's useful, but it's even more useful, this process is even more useful when we have an exponential function set equal to a linear function or another exponential function or whatever. So let's say we had two populations that were growing differently, 100 times 1.1 to the x and 100 plus 10x. So notice the first one is exponential, growing at 10% per year. The second one is linear, growing at 10 people per year. When we graph these, again, we're going to need to adjust our window here a little bit. All right, let's try this. Let's try negative 10 to 10 again. And let's keep everything else the same. Again, you have to play around with your window a little bit, right? You're not always going to find an easy window to work with. You have to make some adjustments. So let's graph and see what we get. Y1, first one is our exponential function. And then we also have a linear function. This is actually a bad example because there's only one point which these are the same. But let's choose a different one here. Let's choose a function that's actually growing faster. Okay, so this one is gaining 20 people per year. Let's try this again. So the slope will be a lot steeper. Okay, so we see that they're initially the same, right? And in this case, we're talking about population, so we don't really care about negative time. So we can change this y minimum to 0. Okay, and we can see that there's going to be another point of intersection sometime out of the range of this window. So there's our exponential function curving slightly, right? And there's our linear function going straight. So let's go out here to the right a little bit. Let's go to 20 again. And then I think we'll be okay in terms of our y max. Well, let's find out. Let's graph it. Okay, so that allows us to see the intersection of these two functions on the same window. So we can take a look here. Once again, second trace, number 5. And then we're going to do first curve, second curve, and then we're going to guess. Notice it is important here to guess, to put your guess close to the intersection because there are 2 points of intersection. There's another one down here at 0, 100. So that's close enough. And then there it is. Oh, and that's interesting. It's about the same as the last one, about 14. That's really interesting. Notice that the population at that time is about 380. So very interesting, coincidental, but just interesting to know. So that's the 2 methods. If you have any more questions, you're welcome to ask me on Facebook. If your calculator is doing something weird or different, just let me know. Remember, if you turn on your stat plots, right, if these are turned on, your calculator might not graph correctly. So please turn those off before graphing. Make sure those are all not highlighted. Okay? Good luck, and I'll see you in class tomorrow.